So hello and welcome back. So in this video we are basically doing example number 6 on page 471, and basically before I do that I would like to say something to you about these exponential functions here that we are talking about. So I kind of feel that the flow of the curriculum in this part of the book, in these few pages related to exponential functions, is not very natural. There is a few more things that could be said about exponential functions, and well, they are kind of missing. So I decided to change the natural flow of the book here in this part, but then I changed that decision. I decided to do that, to go on based on the natural flow of the book, and then whenever it's necessary, I'm going to add a few more basically additional material to this part of the book so that you can understand exponential functions better in the very context that they are actually used in the real world. So basically, if you feel that you don't really understand what's going on with these exponential functions, you don't need to worry about it. We will add additional material to this part of the book so that you can have a better idea of what exponential functions really are and how they are used in the real world. Of course, I have tried to basically fit in or add some explanation to even these parts that we have gone through so far. But if you don't really get it, then we will add more material to this part of the book. So with that said, now we are going to do example number 6 on page 471, and well, it's about writing an exponential function. It's about writing an exponential function given its graph. So you can see the graph of the function over here. One of the points is 0.0, which is this point, 0,3. The other point is 2,12. So this point over here is 2,12. So you know 2 points on the graph of the function, and this is going to be the initial value of the function, 0,3. And why I'm saying that is that basically you know that the general form of exponential function is f of x is equal to a times b raised to the power x. So the initial value of the function is basically where your x is equal to 0. So when your x is equal to 0, your function starts with this initial value. And why we call that the initial value is very simple, and it's basically very fun to know that and understand that. Let's say you already have $4. You have $4, and you get, and of course let's say you're working somewhere and you get $10 an hour or $12 an hour. So plus $12 an hour. $12 an hour. So in that case, if you already have $4 and get $12 an hour, at the end of the day, how much money are you going to have is that It depends on how many hours you worked that day. So you already had $4. So let's say you worked for $8. You worked for 8 hours. So you had $4 plus $12 times 8 hours, because you worked for 8 hours. So 12 times 8, which is whatever, it's 80, 16, so 96 plus 4 is $100, if I'm not wrong. I don't know. Let me see. I think it's right. Sometimes I make mistakes. 12 times 8 plus 4, which is 100. Okay. So now this is an expression that tells you how much money you have at the end of that day. So basically, how you can rewrite this is that you already had $4, and then you get $12 an hour. So if you take the number of hours as x, then you have 12 times x, and this expression then gives you the number of the amount of money that you have after x number of hours, for example. And let's call this f of x. And then if you work for 8 hours, then your x is equal to 8 hours. So then f of 8 is equal to 4 plus 12 times 8, which is again the same thing, which is equal to 100. So basically here we said that I had already $4. So this is, and this comes into, of course, this function as well. You can see it over here as well. So this is called the initial value of that function. That means this function starts with the value 4. And if you want to draw the graph of this function, it will be something like this. So let's say this is 2 and 4 and 6 and 8. So this is 4. And then you have 12 times x. So your function starts here when your x is equal to 0. 12 times 0 is equal to 0, and then f of x is equal to 4. So your function starts here, and then it becomes something like this. Now, of course, I didn't do the slope right, but it's going to be something like this. It's a constantly growing function, and it's a straight line. So your initial value here is 4. Now what happens here is that your initial value here is equal to 3, and in this function, so basically this whole term has to be equal to 1, so that the value of the function is equal to a. So when is it happening that that b raised to the power x is equal to 1? X has to be equal to 0. If x is equal to 0, then whatever b might be, b raised to the power 0 is equal to 1, and then you have f of 0 is equal to a. So f of 0 is equal to a means that a is the initial value of the function. So then so here basically all that I said, I guess I talked a lot, but I guess you get the idea that the initial value of the function is your a, and you can see it on the graph of the function where the function cuts the y-axis. So I'm going to delete all this right now. I don't need it anymore. So, I have to change. Okay. Okay. So basically this is the value of your a. So here your a is equal to 3. And well, basically x is x, you don't need to worry about x. So I want to write the expression of this function, the equation, an equation for this function. So your a, you know that it's equal to 3, and you have another point on the graph of the function, which is 2, 12. So 2, 12 is another point on the graph of this function, and from this you need to figure out what your b is. So you can use the general form of this function, which is f of x is equal to 8 times b raised to the power x. Here your f of x is 12, because 12 is the output of your function at this point, and 2 is the input. So instead of f of x, you can simply write 12 is equal to a, which is equal to 3 here, times b, which is b, of course I don't know what it is, and x, which is x. So b raised to the power x is equal to 12 divided by 3, which is equal to 4. So now I can write b raised to the power x is equal to 4 if b raised to the power x is equal to 4, oh, and your x here is, your input is here is equal to 2. Okay, so your input is equal to 2, so b raised to the power 2 is equal to 4. So this b, of course, is equal to 2, because 2 raised to the power 2 is equal to 4. And this is your b, and this is your a, and now you can write the equation of the function, which is f of x is equal to a times b raised to the power x. Now f of x is equal to a, which is 3 times 2 raised to the power x, and that is the equation of this function. So basically, whenever you see, even if you didn't have all of these that now you have here, even if you didn't have the graph of the function, and the only thing that you had was this equation. Now based on this equation, you can see, you know basically that now I want to draw the graph of this function only based on this equation. So I have a function like this, and I know that it's an exponential function. Let's assume that it's an exponential function, and so I know that this 3 tells me the initial value of the function, which is 1, 2, 3. So this is 1 point, and then I can simply put x is equal to 1, and then 2 raised to the power 1 is equal to 2. 2 into 3 is equal to 6. So 1 and 1, 2, 3. So this is 3. So this is 6. And so then this becomes the graph of this function. Something like that. So basically, based on this formula, based on this equation, you know where the initial value of the function is. So that's basically all you need to know about example number 6. I'll see you in the next video. Thank you.